Okay, here is the solution to day 4, problem 1. A person is 5.5 feet tall and casts a 4-foot shadow. At the same time, a nearby building has a 30-foot shadow. Question A, sketch a diagram. So let's say that this is the ground. Let's make a person and nearby a building. For a building, maybe just a simple rectangle shape here. If the sun was in the sky in the upper right, so that the sunbeams come down like this, and then the sunbeam right from the sun way up high in the sky is coming down past the person's head, that's how shadows would be created on the ground. There will be a shadow here on the ground for the person, and there'll be a shadow here on the ground for the building. If the sun was way up high in the sky to the right, then the sunbeams are coming down from the upper right. We can look at this drawing and hopefully by now notice some right triangles. Here's a right triangle located where the person is, and here is a right triangle located where the building is. The person is 5.5 feet tall, so this side gets labeled 5.5, and the shadow for the person is 4 feet. We don't know how tall the building is. We can label that X, and the building shadow gets labeled 30 feet. So here is our diagram for question A. Now in question B, use the similar triangles that we have there to create a proportion that we can use to find the building's height. So because the triangles are similar, we can compare the measurements in those triangles. Looking at the triangle for the person, the height of the person can be compared to the shadow of the person. And then in the similar triangle for the building, we can compare in the same order. The height of the building can be compared to the shadow of the building. Here's our proportion. Now, there are no patterns that are extremely evident to me between 5.5 and 4, or even trying to compare the 4 to the 30. Nothing jumps out at me as being an obvious pattern. So I'm going to solve this proportion in the same way I would solve any equation for the letter x. Here is the variable x. Right now it says divide by 30 next to the x. We can remove the divide by 30 by multiplying by 30. And so times by 30 on the right side of the equation, and to maintain balance, times by 30 on the left side of the equation. When we do this, what's going to happen is that this 30 will cross-cancel this 30, leaving the x alone. That's what we were trying to accomplish. Now on the left side of the equation, 30 times 5.5 divide 4. We just need to work out what that number is, and that will be the answer for x, which is the building's height. So let's take a calculator and find that result. 30 times, now I want to type in 5.5. 5.5 is a mixed number. There's various ways to type in 5.5. A quick way to type in 5.5 is to type it in as a decimal. Do we know the decimal for 5.5? Hopefully we do. That's 5.5. 0.5 is the decimal version of a half. So there's what it makes. 30 times 5.5. And now we can do the divide by 4 piece. So divide by 4. Enter. 41.25. Feet. And so we were able to find the height of this pretty tall building, not by measuring the building, but indirectly, because there was a person standing nearby and a shadow. And by measuring the person and the shadow, That allows us to get the height of the building through indirect measurement. Day 4, problem 2. There are 4 questions here. Let's start with question A. 5 times negative 14. Positive times negative is negative, and then we have to figure out what 5 times 14 is. So 14 times 5, 4 times 5 is 20, carry 2. 1 times 5 is 5, plus 2 is 7, 70. So our answer is negative 70. Question B, negative 42 divided by negative 7. Negative divided by negative makes positive, and 42 divided by 7 is 6. Question C, 5 halves, subtract 2/3. Subtracting fractions is when you need to have the same denominator. So let's change these fractions so that the denominators are the same number. You can multiply the first fraction by 3/3, and that will change it to 15/6. And we can multiply the second fraction by 2/2. That will create 4/6. And now that both fractions are measured in sixths, we can subtract them. 15 subtract 4 makes 11/6. Question D. 5/20 divided by 5. One way to do a division problem involving fractions is to change the problem into a multiplication problem. Dividing by the whole number 5 is equivalent to multiplying by the fraction 1/5. 1/5 is called the reciprocal of 5. 5/1, you take 5/1, turn it upside down, it becomes 1/5. And now we can do this multiplication problem. 5 times 1 is 5. 20 times 5 is 100. Does 5/100ths reduce? Is there a number that divides into 5 and into 100? And there is. They both can be divided by 5. That will create 1/20. And that makes sense, right? If the original problem is 5/20 and we divide by 5, then each group we create would have 1/20 in it. We'd have 5 groups of 1/20. That's 5/20.